Jai Hind everyone. Today I am going to discuss one of the shortest path calculating algorithm, that is Floyd Warshall algorithm. As we are discussing the subject DA, design and analysis of algorithm, there are multiple algorithms, and we have studied earlier also that there are multiple methods or techniques to design an algorithm. So Floyd Warshall algorithm basically follows the dynamic approach. So we can say that Floyd Warshall algorithm is one of the application which follows the dynamic approach. And what dynamic approach says? Dynamic approach says that you have to find out the optimal solution for the given problem. It gives the optimal solution. So how we find out the optimal solution? After calculating all the possible solutions, we generate the optimal solution, because this is only the way which dynamic approach follows. So now first of all we should understand the statement of Floyd Warshall algorithm. The Floyd Warshall algorithm is basically used for calculating the shortest path between all the nodes of the graph. As we have discussed earlier also, that in Discastra algorithm, the algorithm generates the solution for single source shortest path, means from single node we calculate the shortest path till destination. But in case of Floyd Warshall, each and every node is path calculated. So whenever we are given with a graph G with vertex V and edges E, it compares, it calculates all the path between all the edges existing, all the vertex existing within the graph. Its time complexity is O of V cube. Okay. Next, Floyd Warshall algorithm also support negative weight edges, means the weights in a graph can also be negative. As in Discastra algorithm we discussed the weights can be positive only, but in case of Floyd Warshall algorithm we can have negative weight also. But we shall assume that there are no negative weight cycles. So this is a constraint with Floyd Warshall algorithm, that there should not be any negative weight cycle. Although negative weights can exist, but negative weight cycle cannot be present within the Floyd Warshall algorithm. So a graph which can have positive weight as well as negative weight can be considered for calculating Floyd Warshall algorithm, but one constraint is there, that there should not be any negative weight cycle. So this point is to be remembered. Next, how to calculate the shortest path? We use different methods for calculating. We use various multiple paths. So first of all we calculate the direct path. After calculating the direct path, we calculate all possible path from the desired node using other nodes as the intermediate node. We will look into the numerical, then you will get a better picture of this scenario. So let us assume this is the graph. So one way is to reach from I to J is direct path, that we can reach, we can commute from I to J. But second way is we can go through K. First from I to K and then from K to J. So there are two ways or two path to reach J from I. So we have to explore all the path and we have to find the cost of each and every path, and whatever path gives us the minimum result, minimum cost, will be the optimized one, and we will go with that only. So this is the recursive formula which is going to be used in the algorithm, that is weight of Wij if k is equals to 0, means if there are no k exist, means there is no intermediate node between I to j, then weight of I to j is the only cost. If there is no such path, if suppose I say there is no k node present here, so how I go to j from I can commute directly, and if the cost of I to j is 5, suppose from I to j the cost is 5, so I have to pay 5 only. But second case is, if there exists a k node, then what? We will go with the minimum cost. Minimum cost of what? Direct path, that is dij k minus 1 or dik plus dkj. Means if I suppose say I to k cost is 1 and k to j cost is 2. Now using k, I can reach j by adding the cost of these two paths, that is 1 plus 2, that is 3. So which is minimum, 3 or 5? 3 is minimum. So I will go with 3. So this is the formula written. That is direct cost or the cost which is calculated based upon the intermediate nodes. So when k is 1 or more than 1, then only we can calculate this thing. So this is the recursive formula which is used for calculating the cost of the nodes. Now this is the algorithm which is involved. So first what we have to do, we have to write the identify the number of rows. So here n represent number of rows. So W is the weight. Now D0 is the matrix which represents the initial costing, initial weights of the graph. Whatever weights are given within the initial graph are being presented in the matrix form in D. Now after that, for k is equals to 1 to n, means all those number of nodes are represented by n. So for k equal to 1, what we will do? We will find out each and every path for I to j. So inside k to k loop, we have I loop and then j loop. And what we have to find? We have to find the minimum cost. So minimum cost between the direct path or using k. The formula is the same which we discussed in the previous slide. And after that, we will return dn. So how many times this process is being repeated? That is n times. So as you can see, this particular is used under this n is used, this n is used. So we can compute the complexity, that is VQ, as we have discussed in the previous slides, that what is the complexity of the algorithm? That is O of V3, and V3 are what? Is the vertex. Now let us discuss one example. So let us assume this is the graph given. As you can see that there is negative weight also present. So first what we have to find out? We have to find out as we can perform Floyd Warshall in this particular graph or not. So what is the constraint for that? There should not be any negative weight cycle. So here we are having negative weight -4. Now just check. This is the cycle coming. This, then this, and then this. This is the cycle completing. Now calculate the weights. -4 plus 6 plus 7. The result is positive. It means there is no negative cycle present. And for this -5 also, we have this, this and this. -5 plus 4 plus 1, that is 0. Again we are having a positive value. So we can perform Floyd Warshall algorithm in this particular graph. Now the first step. What first step says? You have to create a matrix D0 for the given graph. So how to create a matrix D0? So what we have to do? First of all, we have to identify total number of rows in the matrix. So how many rows are there? As we have discussed, total 1 to n. That is total how many vertex are given? 5. So how many rows are going to be there? 5. So for 5 rows, and similarly you will be having 5 columns. Now fill the weights which are given in the matrix. So as you can see, from 1 to 2 weight is 2, sorry 3, weight is given 3. So 1 to 2 weight is 3, we will write here 3. 1 to 1, 1 to 1 weight given is 0 as there is no self loop attached here. Similarly 2 to 2, 3 to 3, 4 to 4, 5 to 5 means we can say when I is equals to j and there is no self loop given within the graph, we can say that all these values are equivalent to 0. So I can fill the diagonal values as 0 because here I and j are equal. So for 1 to 1, 2 to 2, 3 to 3, 4 to 4 and 5 to 5, zeros are filled. Next for 1 to 3, 1 to 3 direct path is there and what is the cost? It is given 8. So we will write 8 here. Next 1 to 4, no direct path is given. 4 to 1 is there but 1 to 4 is not there. So in this particular case what we will do? We will write infinity. As there is no such path exist. There is no direct path between 1 to 4. Next 1 to 5. 1 to 5 we have minus 4. So what we will write here? Minus 4. Next 1 to 5 are completed. Next consider node 2. Now starting from 2 to 1, 2 to 1 there is no direct path. So what we will write? We will write infinity. 2 to 2 it is 0. 2 to 3. 2 to 3 again there is no direct path. So what we will write? We will write infinity. Next 2 to 4. 2 to 4 there is a direct path and weight is 1. So what we will write? We will write 1 here. Next 2 to 5. 2 to 5 again there is a direct path and the weight given is 7. So we will write 7 here. Next come to 3. Node 3. Node 3 when we start with node 3 again check 3 to 1 there is no direct path. So what we will write? Infinity. 3 to 2 weight is there, we will write 4. 3 to 3 it is 0. 3 to 4 there is no direct path. 3 to 5 again there is no direct path. So what we will write? We will write infinity. Next 4. 4 to 1 direct path is there. What we will write? 7 as 2. Okay, this is the weight given for 4 to 1. Next 4 to 2 no direct path is there. 4 to 3 we have minus 5. 4 to 4 it is 0 and 4 to 5 it is again minus infinity. Next 5 to 1 there is no direct path. 5 to 2 there is no direct path. 5 to 3 there is no direct path. 5 to 4 value is 6 and 5 to 5 is 0. So in this way we will create D0 matrix. Similarly you have to create pi 0. Pi 0 is the parental matrix which gives you the result what is going to be the previous node of the current node. Means if you are at 3, so you are reaching 3 using 1 or using 2. What is the predecessor node of 3? So this particular matrix will give you the answer of this particular question. So again in this we are having 5 by 5 matrix. So similarly for pi also we will be having 5 by 5 matrix. 1, 2, 3, 4, 5. So whenever we find out the source node, so the value is 0. There is no cost. It means source and destination nodes are same. And similarly when we are talking about infinity, again it means there is no direct path between the data. So what we will write in place of reaching 1 to 1? What is the source node? Source and destination are same. So what we will write? We will write nil. Next from 1 to 2. 1 to 2. What cost we have written? We have written 3. So we have reached 2 and what is the predecessor node of 2? It is 1. So what we will write here? 1. Node number 1. Now for 3 we have written 8. So we are reaching 3 by paying 8 from 1. So what we will write here? 1. Next is infinity. It means we cannot reach 4. So when we cannot reach any particular node, what we will write? We will write nil. Next is 5 and it is minus 4. So we are reaching 5 by paying minus 4 from 1. So what we will write here? 1. So in similar way, you will fill the matrix and you will get a matrix like this. So in this way, you have initialized your matrix D0 and pi 0 from the graph. Next, what we have to do? We have to find the optimal solution. So till here, what we have did? We have found out the, we have converted the graph into the matrix form. Now what? We have to apply the formula. Which formula? This one. For each and every cell, we have to calculate the cost. Either the current cost is minimum or the new cost which we are going to calculate is minimum. So, next step, we will calculate D1. Now, what D1 says? First of all, consider whenever the cost is 0, that is diagonal elements. We will not go with the diagonal elements because those are the source and destination are same. But from D1, what we are going to calculate? First of all, we will calculate the cost of this cell, then this, then this, then this, each and every cell. If that particular cost is minimum, whatever we are calculating, then we are going to replace. And if the cost is not minimum, is more, then in that particular case, we are not going to change the value. For example, if I take, this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have to calculate Dij. Okay. So Dij, initially I consider this value. Okay. So 1, 2. I have to check whether I have to replace this 3 or not. So what I will do? I will calculate for 1, 2. So I is 1 and j is 2. Now for I equal to 1, j is equals to 2 and k is 1 only. K is 1 here because we are calculating D1. So this. Now what formula says? Minimum of Dij k minus 1, okay, k minus 1 कितना हो जाएगा 0. So at D0 Dij means this is D0, Ij is 1, 2, that is 3. So what is the value here? That is 3, minimum of 3. Next, what has been written? It is written Dik k minus 1 plus D kj k minus 1. I have to choose among these two. So Dik k minus 1. So Dik k minus 1. What is the value? K is 1. So D11. This is D11 in D0. So in D0, 1, 1 value is 0. So it is 0 plus K is 1, J is also 1. That is D11, that is again 0. Okay. So what we are going to get? We are going to get 0 value. So there is no change. We are not getting the optimal solution. We are having this 3 only. Okay. As in this particular thing, we are having value 0. Next, let us assume the value of this particular cell. This particular cell is having value infinity. And what is the cell? 4, 2. So now calculate the same thing for 4, 2. Okay. For 4, 2, what we are going to write? We are going to write minimum D 4, 2, K minus 1, that is 0, comma D 4, 1 plus D 1, 2. Now find out the value. So for 4, 2, it is given D 4, 2, it is infinity. We will write infinity here, comma D 4, 1 in 0 matrix. D 4, 1, 4, 1, it is 2 plus D 1, 2. D 1, 2, check 1, 2, that is 3. So what we get? Minimum of infinity, comma 5. Which is minimum? 5 is minimum. So we have find out that what is the value of this? Infinity is replaced by 5. And as we have replaced it by 5, so how we are reaching here? By paying cost 5. Check the graph. It is written we are reaching 4 to 2. 4 to 2 using 1. So 4 to 1 and 1 to 2. The cost is 2 plus 3, that is 5. So what is the predecessor node of 2 here? That is 1. So the predecessor node is 1. So in parent matrix also we will change, we will write 1. Or on the other side we can say we will consider only node 1 as the intermediate node whenever we are calculating the data for any of the cell. Let us again assume we will calculate this minus 2. Now how to directly calculate the value? Each and every time we are going to implement this formula only. But we can solve this problem directly from the graph also. So for this value, we have to find out 4, 5. Can 4, 5 be updated? So 4 to 5, direct cost is what? Infinity, because there is no direct path present. So using 1, can we reach 5? So 4 to 1 and 1 to 5, yes, we can reach. So 4 to 1 cost is 2 and 1 to 5 cost is minus 4. So 2 plus minus 4 is minus 2. So by paying minus 2, we can reach 5 using 1. So what we will write here? We will write minus 2 and its parent will also change, that is 1. In similar way, we will calculate D2 and D3. The concept will remain same, but a single thing change. Whenever we are calculating the further matrices till D5, what will happen? As while calculating D1, we have included only node 1. Then when we are calculating D2, we will include node 1 and 2. When we calculate for D3, we will include node 1, 2, 3. When we calculate for D4, we will include 1, 2, 3, 4. And when we calculate for D5, we will include 1, 2, 3, 4, 5. All the 5 nodes will be included. So step by step, intermediate nodes will be increasing. And based upon that, we will find out the optimal solution. So I hope the concept is clear. You can go through the slides and find out the results. And while you are solving, you can solve each and every matrix by using formula also or directly from the graph also. So these are the references. Thank you.